I don't have time to edit this video, but I want to tell you something, and I think it's appropriate for this day. Did you know Jose Rizal was very brilliant in physics and mathematics? Yes, he's absolutely. I mean, I I don't pay attention much to Jose Rizal, but I know that he's the national hero of the Republic of the Philippines, and that he's the one who wrote Nolomi Tangere and El Filibusterismo. And as a guy who likes physics and mathematics, of course, I dig deeper into his life related to physics and mathematics. So, right now, I'm going to tell you his life in physics and mathematics. Well, we know that he's not a physicist or a mathematician, anything like that. He took medicine. I know, I know he took medicine. He's a doctor in the eye. I forgot what it's called, but yeah. But we're going to talk about specifically his brilliance in physics and mathematics. So in 1872 until 1877, he studied in Ateneo Municipal Manila de Manila, Ateneo Municipal de Manila. There we go. And I'm reading here right now, according to his grades in physics and mathematics, and he got a excellent grade, or in Spanish, that's called sobresaliente. Um, and according to his grades here in Ateneo Municipal de Manila, he has very excellent grades, surprisingly, very excellent grades in subjects such as arithmetic, algebra, geometry, and trigonometry. And same thing here in physics and chemistry. He got an excellent grade. So at the Ateneo, which was equivalent to high school and junior college, so basically, Rizal was an exceptional student. He was brilliant, and he has a brilliant mind. Even Jose Rizal in his earlier career, earlier education life, he was an exceptional student. He was brilliant, and he graduated with the degree of Bachelor of Arts, with the highest honors, by the way. Absolutely brilliant, absolutely brilliant. And to talk about this in Rizal Day, I think that's very appropriate for me as a physics and mathematics fanatic. So, okay, so moving on. In 1877, he studied next in UST, or University of Santo Tomas. So his academic performance here in UST, he studied philosophy and later on medicine, just like Sis said. Um, it wasn't He didn't kept the momentum of excellent. Um, his grades in physics and mathematics were like mostly very good, uh, very good. But still, he still had other subjects where he still got the excellent grades. But when it comes to physics and mathematics, he only got like very good grade. But at least he passed. At least it's very good. Not a terrible grade. So according to his grades here in UST, in his preparatory course, he took advanced physics and mathematics. So here he received a grade of aprovechado, if I read that right in Spanish, or which means very good or notable. So in physics, particularly in advanced physics, he only got a very good grade. But hey, it wasn't that bad. Well, while he didn't maintain a straight A record in the university, as he did in Ateneo, of course, compared to his grades back in Ateneo, he had very excellent grades in chemistry and physics. Well, his grades remained in the top tier of the class, and I guess that's fine. That's good, because I mean, for instance, in his medical studies, he was one of only a few students to receive high marks in a challenging curriculum. He's very excellent in medical studies. I mean, of course, that's that's the course he took. and not physics and mathematics. So I wouldn't be surprised. I mean, for someone like me who really likes physics and mathematics, his grades in physics is very good, very well. I mean, I'm very surprised. Very good. And like physics that time is also a pretty hard subject. Physics that time is a very hard subject because that time during Jose Rizal's era, there was no such thing as theory of relativity. There's no such thing as quantum theory. That time, those theories were still being developed by physicists. So physics is really hard to understand because we don't have these theories that would further understand our natural laws, our natural physical laws of our world, of nature itself. So I'm pretty sure Rizal that time struggled with the Newtonian mechanics or uh, Lagrange, Lagrange mechanics. I don't know if Lagrangian mechanics were also being studied by that time, but I think it's mostly Newtonian because Newton was very popular in physics, especially even during Jose Rizal's era. Newton was very exceptional, was an exceptional figure in physics. So of course they would teach that, including the Spanish. Okay, so moving on. Let's go on with his works. Okay, so in his work here in chapter 13 of El Filibusterismo, it's actually titled as the physics class. The physics class, or La clase de física, if I read that correctly in Spanish. It's interesting because I like physics, and chapter 13 of El Filibusterismo, written by Rizal, is the physics class. And it's incredible. And let me look at how fanatic I am in physics and mathematics. I wrote those. It's still in my wall, by the way. Look at that. All of that is my doing. All of that is my doing. Just that's just how much I love physics and mathematics. So whenever I see the word itself, my eyes perk up. Like whoa, I love this subject. And then Rizal pulled out this chapter 13 of El Filibusterismo, which is the physics class. So basically, in this chapter, Rizal talks about the mysterious cabinet. So here's the problem during Rizal's time, right? The education system during the Spanish colonial era. And I think this also applies to other European countries. Specifically, Einstein. Einstein had the similar experience before. Albert Einstein had the similar experience as Rizal did. Because according to this chapter, this mysterious cabinet can only be admired from outside. You cannot use this equipment because inside the mysterious cabinet are filled with tools for measurement, tools for experiments in science and chemistry, yet students in this chapter cannot use it. And as I read here, Rizal had a critic in rote memorization, which Albert Einstein also did. Albert Einstein also hates rote memorization because it doesn't work. That's not how education works. And it just shows how bad the situation in education that time. It just shows how bad the educational system was at that time, especially in Rizal and Albert Einstein's era. Like brilliant minds like Rizal and Einstein were also very concerned about this. And I'm pretty sure other physicists like James Clerk Maxwell and also Max Planck is also very concerned of this educational system. So he depicts a student, which is Placido Penitente, in a classroom where science was taught through memorization rather than observation. So Rizal likened the students to phonographs or steam engines that could recite definitions, like the definition of a mirror, without understanding the physical principles behind them. So what Rizal was saying here is that during his era, how the education works is you're being taught what to think and not how to think. So, in other words, um, they don't show you how it works. It just tells you to memorize definitions, for the sake of good grades. They build you a mindset where you just have to get good grades. It's just pretty much it. It's boring, right? It sounds boring. That's why people hate people even nowadays hate school, because the education system is still pretty, pretty terrible, And here, like, while Rizal was primarily a medical doctor, and now, okay, I finally found the term here for the doctor of eyes, which is ophthalmologist and naturalist. Okay, he's a naturalist too. Very surprising information for me. It's my first time to know that Rizal was a naturalist. I forgot. I think I forgot. I think I've heard that he is a naturalist before, but yeah. His knowledge of physics was integrated into his broader scientific and engineering pursuits. And this is where I was shocked about. Rizal was actually using his knowledge in physics. Wow. I was like, what? What? During his exile in Dapitan, Rizal applied his knowledge in physics and chemistry, um, the principles of physics to be specific, and engineering to design a construct, a community waterworks system. He built a community waterworks system? That's insane. And then, according here, he built a dam and a series of pipes using clay and stones to provide fresh water to the town. And I think that's absolutely impressive for Jose Rizal, even himself. I mean, I'm very shocked. Like, whoa, he did this? He built a dam and a series of pipes using clay and stones only to provide fresh water to the town. That's amazing. He applied physics just so he can help his community, and that's why Rizal is beyond just good because of El Filibusterismo and Noli Me Tangere. He built this using the principles of physics. And that's incredible. Physics and engineering, he applied those just so he can help his town to have fresh water. And I think I think this fact should not be ignored, especially in history class. That because I'm pretty sure they just teach how Jose Rizal was a national hero by writing El Filibusterismo and Noli Me Tangere, but not these contributions as well, such as water systems for the entire town, to the town. And that's insane. That's absolutely insane. And also, in El Filibusterismo, he describes a complex time bomb hidden inside a kerosene lamp, by the way, which is a weapon for Simon. And this description involved an understanding of chemistry and mechanics. And that's also impressive. That means he's still using his knowledge in physics just so he can make his book absolutely amazing to read. And I should have read the entire book of El Filibusterismo just to know how he explained the time bomb. Anyways, as mentioned previously, Rizal studied advanced physics at both the Ateneo and UST. And his notes and letters suggest he viewed physics as a tool for progress and a way to challenge superstition through pure observation. Amazing. I agree, Mr. Rizal. I agree that physics is a tool for progress and a way to challenge superstition through pure observation. And I agree, Mr. Rizal. I agree. So basically, Rizal believed that physics and other natural sciences are essential into making our country better. And it's also essential for the national liberation of the Philippines. And he argued that science should not be kept dead. So we need to understand more about science. We need to understand more what is science, and not just what is science, but how is science. we need to just see it, not just know it. We need to see how this works. This is the wonders of science is seen through a vision, and not just by listening, not just by seeing equations, but also by visualizing how these equations work to until it transforms into something fantastic. And that's what I like about it. That's what I like about Rizal's point here. It's basically, it's not just about freedom for the Filipino people. It's not just about uh, better treatment to the Filipinos, but it's also about how science should not be dead, how the education system should be changed. Rizal and Einstein always pointed out that people should not be taught what to think, but how to think. They need to teach children how to think of many concepts. We need to promote a educational system where thinking is dynamic. Thinking is diverse. Thinking is diverse. We cannot think the same way. We need to think differently, but all lines connect to the same point, which is physics, or which is arts, which is Filipino, which is English, any subject. We need children to think differently, to think outside of the box. Just think outside of the box. Like, think of other ways. Like, how can I solve this problem in a way that is much more easier? That should be the mindset. We should know other ways to solve a problem that we find easy to do, that we find more efficient, more convenient, that makes sense and still upholds and protects your own principles. And that's amazing. Now, before I end this video, I would also like to point out his travels from outside the Philippines and his era here, the physics in Jose Rizal's journey. So, as we all know, Jose Rizal lived from June 19, 1861, and of course he died in December 30, which is right now, in 1896. 1896, December 30, he died during the execution in Rizal Park. This period was one of the most explosive eras in the history of science. And it's very symbolic to know that Jose Rizal died in a day, in an era where science was about to be changed forever. Why? Because this was the transition from classical physics to the dawn of the new physics, which is relativity and quantum mechanics. And to think that Jose Rizal died at this moment where classical physics is about to change, I could not describe how impressed I am to see that Jose Rizal died during that time where physics is about to change forever. Now, so when Jose Rizal was studying in Europe and building his water systems in Dapitan, some of the greatest minds in history were revolutionizing on how we understand the universe. So during his time here in Europe and also building his water system in Dapitan, this is where many of the great physicists were already here with Rizal. Okay, let's start with the first one on the list, which is James Clerk Maxwell. Yes, James Clerk Maxwell was alive during Rizal's era. But unfortunately, of course, James Clerk Maxwell died in 1879, which is years after Jose Rizal's death, which is... Oh wait, no. 1879. He died in 1896. Rizal died in 1896. Okay, so James Clerk Maxwell died first. Okay, so... James Clerk Maxwell is the third greatest physicist after Newton and Albert Einstein. So basically, he's the one who formulated the theory of electromagnetism, and he's also the one who organized the equations for electromagnetism, or what we call the Maxwell equations, which describes the relationship between magnetic fields and electric fields. Basically, in general, electricity and magnetism. So, these equations, these electromagnetic equations formulated by Maxwell, also paved the way to the discovery of light itself. And to think that such relationship between electricity and magnetism also paved the way to the discovery of the speed of light, it's actually very amazing. It's simple. It's simple looking, just using by calculus and some operators, and to think of that, it's absolutely impressive. And by that time, during Jose Rizal was alive, next one on the list is Lord Kelvin. And as you all know, the unit for temperature, which is Kelvin, which we use in physics to calculate for temperatures of gases, or specifically in the field of thermodynamics, well, that came from Lord Kelvin. So he is a leader in thermodynamics. So basically, absolute zero is named after him. Absolute zero is named after Lord Kelvin. He was born in 1824, and then he died in 1907. He was at the peak of his fame during Rizal's travels in Europe. And yeah, we may not know, but maybe Rizal met Kelvin? Who knows? Who knows if Rizal met one of these physicists? Just who knows? So, now here is a much more interesting figure. So we got Heinrich Hertz, 1857 to 1894. So Heinrich Hertz was a physicist who was born in 1857 and he died in 1894. So he was the man who proved the existence of radio waves in 1887, which 1887, it is the same year where Jose Rizal published Noli Me Tangere. So while Heinrich Hertz proved the existence of radio waves in 1887, Jose Rizal also published Noli Me Tangere at this time, 1887. And unfortunately though, Heinrich Hertz died just 2 years before Rizal. And that's very sad. And next one on the list is one of my favorite physicists, by the way. We got Max Planck. So he was born in 1858 and died in 1947, and he was considered the father of quantum theory, or the father of Prussian physics. So he was exactly Rizal's age, but he was like 3 years, born just 3 years earlier. Okay, so he was already a professor in Berlin when Rizal was in Germany. He was already a professor in Berlin. Max Planck was already a professor in Berlin when Rizal was traveling to Germany. And there is a probability, just a probability, that Jose Rizal also met Max Planck, which is the father of quantum theory. And next one, we got Maria. Maria, or what we call Mary, what most people call her, address her as Marie Curie, but I would prefer to call her Maria, and on the other name, which is a Polish name, I can't pronounce it, but I will address her as her actual name, which is Maria. She was a young student in Paris, and she was born in 1867. Anyways, she died in 1934, and she was a young student in Paris while Rizal was there. She was a young student in Paris while Rizal was in Paris. And shortly before Jose Rizal's death, she already began her experiments and works in radioactivity. And that's very sad. I don't know why. I don't even know. There's also a probability that Marie Curie also met Jose Rizal during her life as a young student. But we're moving on to the mathematicians. So if Jose Rizal met those mathematicians, met those physicists during his travels in Europe, then that's cool. But if not, that's okay. Now let's move on to mathematicians in Rizal's era, shall we? Now, first off, in the list, we got George Cantor. He was born in 1845 and died in 1918, exactly the year where World War One ended. He was the one who known for inventing set theory, one of the most important fields in mathematics, which is set theory. This is how we use set theory to prove mathematical statements, theorems, conjectures. Set theory is one of the most fundamental uh, uh, tools for proving a formula, proving an equation, proving a theorem. It's all set theory. Okay, so he was a professor at the University of uh, I can't pronounce this. University of Halle, Halle, while Rizal was in Germany. So he may have met George Cantor as well, as a professor in the University of Halle. Okay, I'm not wearing my glasses, so you may notice my eye moving sideways. Okay, next next one is uh, Lewis Carroll or Charles Ludwig Dodd Dodson Dodgson. I don't know. I can't pronounce. Sorry. Um, During Rizal's lifetime, he was very famous for Alice in Wonderland, and he was a prominent mathematician and logician at Oxford. Oh, so he wrote Alice in Wonderland? Ooh, that's interesting. Okay, next one is Sofia Kovalevskaya. Nice. So, the first woman to hold a professorship in Northern Europe, and she made major contributions to analysis and differential equations and died while Rizal was writing El Filibusterismo. Interesting. Oh, yes, I know this guy. Henry Poincare. He's often called the last universalist because he excelled in all fields of math. This guy excelled all fields of math. He's incredible, and he's also the guy who invented the Poincare um, conjecture, the Poincare conjecture, which is still an unsolved math problem until this day. And even I am trying to solve this, by the way. Um, he was active in Paris during the years Jose Rizal was in Paris. So, um, another thing to point out here, it is very highly likely that Rizal was able to read one of these papers that the mathematicians and physicists have uh, wrote. It's just highly likely. It doesn't mean it's guaranteed that Jose Rizal actually managed to read these discoveries in science and mathematics. Um, and in order for him to discover this is uh, he had to read in European newspapers and scientific journals. Oh yes, during Jose Rizal's time, the true celebrities were scientists and mathematicians. Those were the true celebrities at that time. It was scientists and mathematicians, and they're everywhere on newspaper. And if Jose Rizal was a guy who likes to read newspapers, he might have encountered many of these names before. And okay, so according to Jose Rizal's letters, he often lamented that the Philippines was backward compared to these rapid advancements. Exactly. I agree at that. It's Yeah, the Philippines even now is still kind of backwards to scientific progress because I don't know why the government just doesn't treat science too seriously, because science is an important aspect for the survival of our country. Especially it's one of the biggest pillars for our country's prosperity and progress. So I think the government should stop ignoring uh, science any longer. So here's an interesting fact. And did you know that Adolf Bernhard Mayer, no, not Hitler, not Hitler, not Hitler, Adolf Bernhard Mayer is it's Rizal's close friend in Europe. Rizal and Bernhard were close friends. And Bernhard Mayer was a prominent scientist and director of the Dresden Museum. And through Mayer, Rizal was connected to the broader European scientific community. And though his own scientific work focused more on biology and ethnography, um, it's still he was still the bridge so that Rizal can be connected to the broader European scientific community. So there is still a chance that he managed to read works of James Clerk Maxwell, Max Planck, or even Maria or Marie Curie. It's very likely, and I am I am very glad that I managed to talk to you about Jose Rizal in and his involvement in physics and mathematics, and especially the physicists and mathematicians who were active at that time, where Jose Rizal was still alive. And uh, I would say that Jose Rizal's death should not be in vain. Still, even until now, I think it's important for us to always remember Jose Rizal's death, because, I mean, who wouldn't be appreciative about a man who is willing to give out his life just so he can advocate for reform on the government? All he wanted was a reformation. He just wanted the Spanish government to treat us better, because of course the Spanish were very cruel to us, and Rizal didn't like that and just wanted to advocate that maybe you guys could, lessen your harshness towards us. But unfortunately, that did not work out even after Jose Rizal's death. And through Andres Bonifacio and President Emilio Aguinaldo, they led the revolution that will eventually free the Philippines from the Spanish, which I think wasn't worth it. I mean, it is worth it, but eventually we were occupied by the Americans. And yeah, that's where things started going even more backwards instead of forward. It went even more backwards, because apparently General Luna, which is one of the greatest generals we had during the Philippine American War, was killed by his own men. Wow. We were so screwed. But anyways, I think that's all. Let us always remember Jose Rizal's death, because um, he is a symbol. He is one of the greatest symbols of change. And he will always be one of the greatest symbols of change. Because reformation is constant and it cannot be erased. Because if there's something wrong, if there's an error, we always fix it. We will always fix it, and we will not ignore it. We will fix our problems. And that's what Jose Rizal will always tell you, even until now. If there are problems, we need to solve it. If there are things that we need to reform it. But not at the cost where it is destroying you. This is for the sake of our country, and this is for the sake of the progress in science. Science should be kept alive, and that the spending of the government today in R&D must be increased further. And maybe in the next video, I would like to send a message to the Senate of the Philippines through this video in Facebook, why I want for the spending to be 1% of the GDP, the spending on R&D to be 1% of the GDP. Science must be strong here in the Philippines. We cannot go backwards any longer. We need to grow higher. We need to be better. We need to move forward. And even until now, I think Jose Rizal will still say the same thing. We need to be better. We cannot let his death in vain. Thank you all for watching.